the planet Earth. The story of Earth is the story of wonder, resilience, beauty, and mystery. When we gaze into the night sky, we see countless stars twinkling like ancient lanterns suspended in the darkness, each perhaps harboring its own worlds. Yet, among this cosmic sea, Earth shines as a rare jewel, blue, green, and alive. It is the cradle of humanity, the stage where the drama of life has unfolded for billions of years, and the home that has nurtured the only known sentient species, us. Earth is not just a planet. It is a living system, a delicate balance of rock, water, air, and fire intertwined with the rhythms of life. To understand Earth is to understand not only science but also ourselves, our history, and our future. At first glance, Earth may seem ordinary compared to the vastness of space. It is the third planet from the Sun, orbiting at just the right distance where water can exist in liquid form, a region astronomers call the habitable zone. This simple fact alone distinguishes Earth from countless barren worlds scorched by starlight or frozen in eternal night. But Earth is far more than a sphere of rock orbiting a star. It is a dynamic, ever-changing masterpiece, sculpted by forces both violent and gentle, erupting volcanoes, drifting continents, roaring oceans, whispering winds, and the ceaseless march of time. From its molten beginnings over 4.5 billion years ago to the flourishing biosphere we see today, Earth has undergone endless transformations. It has faced cataclysms that wiped out entire species, only to rise again with new life forms that reshaped its ecosystems. Every mountain, river, desert, and forest tells a chapter of this grand story. Yet despite all of its changes, Earth has always carried one constant: the spark of possibility. The possibility of life. The possibility of evolution. The possibility of civilizations that dream, explore, and question their place in the cosmos. Earth is unique because it is alive. It is not merely a planet made of stone and gas, but a system where biology and geology dance together in a delicate symphony. The forests breathe out oxygen as oceans regulate climate. The atmosphere shields life from harmful radiation, while the magnetic field deflects deadly solar winds. Beneath the crust, tectonic plates shift and grind, shaping mountains and triggering earthquakes. Above, clouds gather to rain, nourishing the soil that in turn nurtures seeds, plants, and eventually animals. Everything is connected, everything is in motion, and everything has a purpose. For humanity, Earth is not only our home, but also our teacher. It has taught us about cycles, the water cycle, the carbon cycle, the life cycle itself. It has shown us resilience, surviving impacts from asteroids, ice ages, and mass extinctions. It has given us resources to build civilizations, fertile land to grow crops, minerals to forge tools, rivers to power industry, and climates that shaped cultures. Yet, Earth is also a reminder of fragility. It teaches us that life exists on a knife's edge, and that to abuse its systems is to endanger our own survival. To truly appreciate Earth, we must examine it layer by layer, as though peeling back the chapters of a living book. We must explore its place in the solar system, its structure and composition, its atmosphere and oceans, its history and evolution, its diverse ecosystems, and the incredible story of life that blossomed upon it. Only then can we understand why Earth is not just another planet, but the most extraordinary world we have ever known. This script will take you on that journey. From the fiery birth of Earth in the chaos of the early solar system to the rise of humans who now look back at the stars with wonder, we will trace the grand narrative of our planet. We will marvel at its beauty, respect its power, and reflect on our role as stewards of this fragile blue sphere. Earth is not just where we live, it is who we are. And to know Earth is to know life itself. To truly understand Earth, one must first place it within the grand architecture of the cosmos. Earth is the third planet from the Sun, nestled between the fiery brilliance of Venus and the rusty desolation of Mars. Its average distance from the Sun is about 149.6 million kilometers, 93 million miles, a distance that astronomers have termed 1 astronomical unit, AU. This specific position is no accident in the grand cosmic ballet. It lies within what scientists call the habitable zone, the narrow band around a star where conditions are just right for liquid water to exist. Without this precise location, Earth might have been a frozen wasteland like Mars or a blistering inferno like Venus. Earth completes its orbit around the Sun once every 365.25 days, giving rise to the cycle of seasons that mark the rhythm of life. The additional quarter of a day is why we have leap years every 4 years, adding one extra day in February to synchronize our calendars with the planet's journey around the Sun. Earth's orbit is not a perfect circle, but an ellipse, slightly elongated, meaning the distance from the Sun varies throughout the year. Yet, contrary to popular belief, this variation is not what causes the seasons. The true reason lies in the planet's axial tilt. Earth is tilted at an angle of approximately 23.5 degrees relative to its orbital plane. This tilt is a masterstroke of cosmic design, for it gives rise to the diversity of climates and the alternating cycle of seasons. When the northern hemisphere tilts toward the Sun, it experiences the warmth and abundance of summer, while the southern hemisphere endures the chill of winter, and vice versa. Without this tilt, there would be no seasonal variation, no blooming springs or colorful autumns. The Earth would be locked in monotonous climate zones, robbing life of the rich diversity it enjoys today. Equally fascinating is Earth's rotation. Spinning once every 24 hours on its axis, Earth's rotation creates the cycle of day and night that governs our lives. The equator, the imaginary line dividing the planet into northern and southern halves, spins at about 1,670 kilometers per hour, 1,040 miles per hour. Yet, we do not feel this dizzying speed, for everything around us moves in unison: oceans, air, and land. This ceaseless rotation, coupled with the planet's slightly flattened shape at the poles and bulge at the equator, also influences the movement of air and water, giving rise to trade winds, jet streams, and ocean currents that shape climate patterns across the globe. Beneath its surface, Earth is not a simple ball of solid rock but a layered structure of incredible complexity. At the outermost layer lies the crust, a thin shell of solid rock ranging from 5 kilometers beneath the oceans to 70 kilometers beneath the continents. Though relatively thin, the crust is home to all human activity: mountains, forests, rivers, and cities. Beneath the crust lies the mantle, a vast region of semi-solid rock that flows slowly over millions of years. The mantle is the engine of plate tectonics, its convection currents pushing and pulling the plates of the crust, forming mountains, rift valleys, and deep ocean trenches. Deeper still lies the outer core, composed mainly of molten iron and nickel. This liquid metal churns constantly, generating Earth's magnetic field, a shield that protects life from the Sun's deadly radiation and cosmic rays. Without this invisible armor, Earth's atmosphere would have been stripped away long ago, just as happened on Mars. At the center rests the inner core, a solid sphere of iron and nickel that endures temperatures hotter than the surface of the Sun. Despite its blistering heat, immense pressure keeps it locked in a solid state. This hidden heart of Earth drives many of the planet's internal processes and reminds us that beneath our feet lies a world still alive with fire. Earth's physical dimensions are equally remarkable. With a diameter of about 12,742 kilometers, 7,918 miles, it is the fifth largest planet in the solar system. Its mass, approximately 5.97 times 10 to the power of 24 kilograms, gives it a gravitational pull strong enough to hold an atmosphere, yet gentle enough to allow creatures like birds to take flight and humans to move freely. This balance of gravity is crucial. Were it stronger, life might never have evolved into the forms we know today, and were it weaker, the atmosphere would have drifted into space, leaving Earth barren. From space, Earth presents itself as the blue planet, a shimmering orb dominated by oceans that cover more than 70% of its surface. These vast bodies of water not only provide a home for countless forms of life, but also act as a climate regulator, absorbing heat, distributing energy, and driving the water cycle. The remaining 30% of Earth's surface is land, carved into continents and islands, shaped by wind, water, and tectonic movement across billions of years. Mountains like the Himalayas, valleys like the Great Rift, deserts like the Sahara, and forests like the Amazon all stand as monuments to Earth's geological artistry. Encircling the planet is the atmosphere, a thin veil of gases that separates Earth from the cold void of space. Composed primarily of nitrogen, 78%, and oxygen, 21%, along with trace amounts of carbon dioxide, argon, and other gases, the atmosphere sustains life, regulates climate, and provides the air we breathe. Its layers, the troposphere, stratosphere, mesosphere, thermosphere, and exosphere, each play vital roles, from weather formation to shielding the surface from meteors and harmful ultraviolet radiation. When we step back and view Earth in its cosmic context, we begin to appreciate just how extraordinary it is. Here is a planet with the perfect balance of distance, gravity, atmosphere, and water. A planet with the power to create and sustain life, to nurture civilizations, and to inspire awe in anyone who looks upon it. While other worlds may hold their own mysteries, Earth remains the one world we truly understand, not just scientifically, but emotionally. For it is not only where life exists, but where life thrives. One of the most remarkable features of Earth is the way its systems work together in harmony, weaving a complex web of interactions that sustain life. Earth is not static. It is dynamic, alive with cycles that endlessly renew and recycle resources. These natural cycles are the planet's heartbeat, the rhythm that connects the oceans, atmosphere, land, and living organisms into one great interconnected system. Without these cycles, life as we know it would not exist. Perhaps the most familiar of these is the water cycle, also known as the hydrological cycle. This eternal journey begins when the sun's warmth causes water from oceans, lakes, and rivers to evaporate into the atmosphere. As this vapor rises, it cools and condenses into clouds, forming intricate patterns across the sky. Eventually, gravity pulls the water back down as rain, snow, sleet, or hail, replenishing rivers, nourishing soils, and sustaining plants and animals. Some of this water seeps underground, forming aquifers that humans and countless other species depend on. The rest flows back into the oceans, completing the cycle. The water cycle is more than just a process. It is the very pulse of life, shaping weather, carving landscapes, and regulating Earth's climate. Closely linked to the water cycle is the carbon cycle, which regulates the delicate balance of carbon dioxide in the atmosphere. Plants and algae absorb carbon dioxide during photosynthesis, converting it into oxygen and organic matter that fuel life on Earth. Animals, including humans, breathe in oxygen and exhale carbon dioxide, continuing the cycle. Meanwhile, some carbon becomes locked away in soils, sediments, and fossil fuels, only to be released again through natural processes like volcanic eruptions or human activities like burning coal and oil. This cycle acts as Earth's thermostat, controlling the planet's temperature. Too much carbon dioxide, and the Earth warms dangerously. Too little and it chills. This delicate balance is why climate change poses such a grave threat today. It disrupts a cycle that has sustained life for millions of years. Equally vital is the oxygen cycle, intertwined with both the carbon and water cycles. Oxygen is constantly exchanged between the atmosphere, biosphere, and lithosphere. Plants, through photosynthesis, release oxygen into the air, replenishing the supply that animals consume through respiration. At the same time, oxygen reacts with minerals, fuels combustion, and drives countless chemical processes. This invisible exchange ensures that Earth's atmosphere remains breathable for creatures great and small, from the tiniest insect to the largest whale. The nitrogen cycle is another unseen yet essential system. Nitrogen gas makes up about 78% of Earth's atmosphere, but in its pure form, it is unusable by most living things. Specialized bacteria in soils and oceans fix nitrogen, converting it into compounds like ammonia and nitrates that plants can absorb. Animals then obtain nitrogen by eating plants or other animals, using it to build proteins and DNA. Eventually, waste products and decaying organisms return nitrogen to the soil, where the cycle begins again. This endless recycling of nitrogen ensures that life has the building blocks it needs to grow and reproduce. Beyond these chemical cycles, Earth also maintains balance through its climate systems. The sun provides the energy that drives winds, ocean currents, and weather patterns. Warm air rises at the equator, where sunlight is most direct, and cooler air sinks at the poles, creating circulation patterns that move heat around the globe. The oceans act as giant conveyor belts, transporting warm water from the tropics toward the poles and cold water back again. These processes not only regulate global temperatures, but also shape regional climates, making some regions lush and fertile while others remain arid and dry. Earth's atmosphere plays a key role in maintaining this balance. It acts like a greenhouse, trapping some of the sun's heat and preventing the planet from becoming an icy wasteland. This phenomenon, known as the greenhouse effect, is natural and necessary for life. Without it, the average temperature of Earth would be -18 degrees Celsius, 0 degrees Fahrenheit, far too cold to sustain the rich diversity of organisms we see today. However, when greenhouse gases like carbon dioxide and methane build up excessively, the balance tips, leading to global warming and severe disruptions in climate. Thus, what is a life-giving system can also become life-threatening if thrown out of balance. The seasons are another example of Earth's natural rhythm. Dictated by the axial tilt and orbit around the sun, spring brings renewal, summer abundance, autumn harvest, and winter rest. These cycles influence the migration of animals, the flowering of plants, and the survival strategies of countless species. Even human cultures and traditions have long been shaped by the seasons, with festivals, farming practices, and social patterns reflecting Earth's eternal dance with the sun. Another crucial regulator of Earth's balance is the magnetic field, generated by the motion of molten iron in the outer core. Invisible yet powerful, this field extends far into space, forming a protective bubble called the magnetosphere. It deflects charged particles from the sun, shielding Earth from solar radiation that could strip away the atmosphere and harm living organisms. During intense solar storms, some particles slip through at the poles, creating the breathtaking auroras, nature's own light show, painting the sky with shimmering curtains of green, purple, and red. Taken together, these cycles and systems form the intricate machinery of Earth's self-regulation. They ensure that oxygen remains plentiful, water flows endlessly, carbon and nitrogen are recycled, and climate remains within habitable bounds. They remind us that Earth is not merely a collection of land, air, and water, but a living system, delicately balanced and deeply interconnected. Every breath we take, every drop of water we drink, every grain of food we eat is part of this grand network. Yet, as resilient as Earth may be, its systems are not indestructible. They can be disturbed, altered, or even broken by natural events such as volcanic eruptions, asteroid impacts, or human activities like deforestation and pollution. Recognizing these cycles and their importance is not only a scientific endeavor, but also a moral responsibility. For in safeguarding Earth's balance, we safeguard the future of life itself. If the geology of Earth is its bones and the atmosphere its breath, then the biosphere is its soul. The biosphere is the thin yet vital layer of life that wraps around Earth, stretching from the deepest ocean trenches to the highest mountain peaks. It is here, within this delicate zone, that the miracle of life unfolds in countless forms: plants, animals, fungi, bacteria, and everything in between. Each organism plays a role, no matter how small, in sustaining the planet's balance and beauty. The biosphere thrives on diversity. Earth is home to millions of species, each adapted to specific environments through the long process of evolution. From microscopic plankton drifting in the oceans to towering redwood trees piercing the skies, from insects that outnumber humans by billions to mighty whales that roam the seas, life takes on forms as varied as imagination itself. This diversity, known as biodiversity, is Earth's greatest treasure. It ensures resilience, allowing ecosystems to adapt to changes, survive disruptions, and continue functioning even in the face of challenges. Ecosystems, the communities of living things interacting with their physical surroundings, are the stage upon which life's drama unfolds. Forests, deserts, wetlands, coral reefs, tundras, grasslands, and oceans all provide unique habitats that sustain specific life forms. Each ecosystem is a tapestry of relationships: predators and prey, pollinators and flowers, decomposers and nutrients, all woven together in cycles of energy and matter. No creature exists in isolation. Every life is connected to another, directly or indirectly, forming the great web of life. Consider the forests, often called the lungs of Earth. Tropical rainforests, such as the Amazon, teem with unmatched biodiversity, sheltering millions of species yet to be discovered. They regulate global climate by absorbing carbon dioxide and releasing oxygen, making them indispensable for life everywhere. Temperate forests, with their seasonal rhythms, nurture a balance of flora and fauna that adapt to cycles of growth and rest. Boreal forests, vast and silent, are vital carbon sinks, storing immense amounts of carbon in their soils and trees. To lose forests is to weaken Earth's lungs and disrupt the very breath of life. The oceans, covering more than 70% of Earth's surface, form another vast ecosystem, the cradle of life itself. Within their depths thrive coral reefs, kelp forests, deep-sea vents, and open waters teeming with life. Tiny plankton, though invisible to the naked eye, produce more than half of Earth's oxygen through photosynthesis. Coral reefs, often called rainforests of the sea, host a dazzling variety of species, from clownfish darting among anemones to sharks patrolling the currents. The open ocean, vast and mysterious, is home to creatures like whales, dolphins, and giant squids. The abyssal plains, some of the most extreme environments on Earth, harbor strange and resilient organisms that thrive without sunlight, relying instead on chemical energy from hydrothermal vents. Deserts, though seemingly barren, are marvels of adaptation. Life here has mastered survival in extremes. Plants like cacti store water in swollen stems, while animals like fennec foxes and camels conserve every drop. These harsh landscapes prove that life finds a way, even in the most unforgiving conditions. Wetlands, often overlooked, are among the most productive ecosystems on Earth. They filter water, prevent flooding, and provide habitat for countless birds, fish, and amphibians. Swamps, marshes, and mangroves act as nurseries for marine life, supporting the delicate balance between land and sea. At the frozen edges of the world lie the tundras and polar regions. Here, in lands of ice and snow, polar bears, penguins, seals, and hardy mosses endure extremes of cold and darkness. Though life is sparse compared to warmer regions, these ecosystems play a critical role in regulating Earth's climate by reflecting sunlight and storing carbon in permafrost. Grasslands, with their endless horizons of tall grasses, support vast herds of herbivores and the predators that hunt them. From African savannas where lions stalk zebras to North American prairies once roamed by bison, these ecosystems showcase the balance between grazing animals, predators, and the land itself. What makes Earth extraordinary is not only the variety of ecosystems, but also the interconnectedness of life within them. Plants harness sunlight through photosynthesis, producing energy that flows upward through herbivores, carnivores, and decomposers. Fungi and bacteria break down organic matter, returning nutrients to the soil for plants to use again. Every species, from the smallest ant to the largest elephant, plays a part in this eternal cycle. Remove one element and the balance shifts, often with cascading effects across the system. Humans, too, are part of this web. We rely on ecosystems for food, water, oxygen, medicines, and raw materials. Yet we are also unique in our ability to alter ecosystems on a massive scale, for better or worse. Through agriculture, industry, and technology, we have reshaped landscapes, redirected rivers, and influenced the climate itself. Our responsibility is great, for in protecting biodiversity, we protect not only other species, but also ourselves. The beauty of Earth's biosphere lies not only in its practicality, but also in its wonder. The call of birds at dawn, the sight of migrating herds across a plain, the vibrant colors of coral reefs, the whisper of leaves in a forest, all remind us that we live on a planet alive with stories, each species a character in an unfolding epic of survival and adaptation. This living tapestry is fragile, yet magnificent, a constant reminder that Earth is not just our home, it is a shared home for countless forms of life. To walk through a forest, dive into an ocean, or climb a mountain is to witness the brilliance of Earth's biosphere. Each encounter reveals a truth, that life is precious, interconnected, and endlessly creative. In the vast emptiness of space, Earth's biosphere is a rarity, a phenomenon we have yet to find elsewhere. It is this uniqueness that makes our planet not only scientifically extraordinary, but also spiritually profound. The story of Earth is written in stone. To understand our planet is to trace its history back through billions of years, across eras of fire, ice, and transformation. The Earth we walk upon today, with its blue oceans, green forests, and living creatures, is the result of an epic journey stretching back 4.5 billion years. This history is divided into chapters called eons, eras, and periods, each marked by dramatic shifts in climate, geography, and life. Earth was born from chaos. About 4.6 billion years ago, in the early solar system, dust and gas swirled around the newborn sun, colliding and clumping into larger and larger bodies. Through a process called accretion, Earth formed as one of these rocky planets. In its infancy, Earth was a hellish world. Its surface was molten, constantly bombarded by asteroids and comets. Volcanoes spewed fire, and oceans of magma stretched across the surface. During this time, a Mars-sized body is believed to have collided with Earth, blasting debris into space. This debris eventually coalesced into the Moon, which still orbits Earth today, stabilizing its tilt and influencing tides. As the planet cooled, a thin crust began to solidify over the molten interior. Water vapor released by volcanic eruptions condensed to form the first oceans. Comets and asteroids, rich in water and organic compounds, may have also delivered key ingredients. Slowly, the planet transformed from a fiery wasteland into a world capable of hosting life. This earliest chapter of Earth's story, called the Hadean Eon, was followed by the Archean Eon, beginning about 4 billion years ago. It was during this time that life first emerged. Though the details remain mysterious, evidence suggests that simple microorganisms arose in Earth's primordial oceans. Hydrothermal vents on the seafloor, rich in minerals and energy, may have provided the perfect cradle for life. These early microbes, though invisible to the naked eye, marked the beginning of the biosphere, the first flicker of biology on a geological canvas. For nearly 2 billion years, life on Earth remained microbial. The Proterozoic Eon saw the rise of more complex, single-celled organisms and, most importantly, the emergence of photosynthesis. Cyanobacteria, also known as blue-green algae, learned to harness sunlight, producing oxygen as a byproduct. Over millions of years, this oxygen began to accumulate in the atmosphere, triggering what scientists call the Great Oxidation Event around 2.4 billion years ago. This was one of the most significant turning points in Earth's history. Oxygen, once toxic to early life, became the foundation for future complex organisms. The skies turned blue, the oceans rusted red as iron reacted with oxygen, and the atmosphere took on its modern character. With oxygen came opportunity. In time, life evolved into multicellular organisms, more complex than anything seen before. The stage was set for the Cambrian explosion about 541 million years ago, when life diversified at an astonishing pace. Within a relatively short geological period, Earth's oceans filled with a bewildering variety of creatures, trilobites scuttling across the seabed, strange predators with claw-like appendages, and the first ancestors of many modern groups. Fossils from this era reveal the origins of most of the body plans we see in animals today. From the seas, life gradually expanded onto land. Plants colonized the shorelines, bringing with them insects and, eventually, vertebrates. Amphibians evolved from fish, reptiles from amphibians, and, eventually, dinosaurs came to dominate the continents. For nearly 160 million years, these magnificent creatures ruled Earth, while the skies were filled with flying reptiles and the seas with giant marine reptiles. Forests grew, continents drifted, and Earth continued to change. But Earth's history is also a tale of extinctions. At least 5 major mass extinctions have reshaped life, each wiping out vast numbers of species. The most devastating, around 252 million years ago at the end of the Permian period, eliminated over 90% of marine life and 70% of land species. Yet from destruction came renewal. New forms of life always found a way to flourish in the aftermath. The most famous extinction occurred 66 million years ago when a massive asteroid struck near modern-day Mexico, ending the reign of the dinosaurs. Dust and debris filled the skies, blocking sunlight and collapsing ecosystems. Yet this catastrophe cleared the way for mammals to rise and eventually dominate the land. In this new world, primates evolved, adapting to forests, then savannas, and eventually giving rise to humans. Our species, Homo sapiens, emerged only about 300,000 years ago, a blink of an eye compared to Earth's vast history. Yet in that short span, humans have transformed the planet more than almost any other force. The geological history of Earth teaches us several profound truths. First, that change is constant. Continents drift, climates shift, and life evolves. Second, that catastrophe and creation are often intertwined. Destruction clears the stage for new beginnings. And third, that Earth's resilience is extraordinary. No matter how many times life has been knocked down, it has always found a way to return, more diverse and complex than before. Today, when we walk across mountains, swim in oceans, or dig into the soil, we are encountering the results of billions of years of transformation. The rocks beneath our feet carry the memory of ancient seas, fiery eruptions, and drifting continents. Every living thing, from bacteria to humans, carries the legacy of ancestors who survived extinctions, adapted to change, and passed on the spark of life. Earth's geological history is not just the story of a planet, it is the story of survival, renewal, and the endless march of time. The story of Earth cannot be told without the story of humanity. For billions of years, Earth thrived with life, but without humans. Then, in a relatively recent chapter of its history, a new species emerged, one that would not only adapt to the planet but also alter it in profound ways. Humanity's rise is both a testament to Earth's generosity and a reflection of the responsibilities we now carry. Our journey began in Africa, where early humans, Homo sapiens, appeared roughly 300,000 years ago. These first humans were hunters and gatherers, deeply connected to their surroundings. They relied on the earth for food, shelter, and tools, observing the rhythms of the seasons, the migrations of animals, and the cycles of plants. Unlike other creatures, humans developed language, cooperation, and the ability to imagine futures. These abilities allowed them to innovate, adapt, and spread across continents, eventually reaching every corner of the globe. Human civilization is inseparable from the gifts of Earth. Rivers like the Nile, Tigris, and Indus nourished the first agricultural societies, giving rise to ancient civilizations in Egypt, Mesopotamia, India, and China. Fertile soils allowed crops to flourish, feeding populations and enabling cities to grow. Mountains provided protection, minerals offered tools, and oceans opened paths for trade and exploration. Humanity's cultural, social, and technological advances have always been rooted in Earth's landscapes and resources. The agricultural revolution, about 10,000 years ago, marked a turning point in our relationship with the planet. No longer solely dependent on hunting and gathering, humans began to domesticate plants and animals, transforming ecosystems to suit their needs. Fields replaced forests, irrigation redirected rivers, and surplus food supported growing populations. With agriculture came permanence, villages, towns, and eventually cities. This revolution reshaped Earth's surface and set humanity on a path toward unprecedented growth. Civilizations rose and fell, often shaped by their environment. The ancient Mayans thrived in the jungles of Central America but faced collapse when deforestation and drought disrupted their balance. The Roman Empire flourished with access to Mediterranean trade routes, but declined under the weight of political instability and resource strain. Time and again, Earth reminded humanity that prosperity depends on respecting natural limits. The Industrial Revolution of the 18th and 19th centuries marked another dramatic shift. Powered by coal, steam, and later oil, humanity entered an age of machines, factories, and mass production. This era unlocked extraordinary progress: railways, electricity, medicine, and global trade, but it also placed immense pressure on Earth's resources. Forests were cleared, rivers polluted, and carbon dioxide levels in the atmosphere began to climb. The balance that had sustained life for millennia was increasingly disrupted by human ambition. Yet humanity's story on Earth is not only one of exploitation but also of awe and discovery. From the earliest cave paintings that celebrated animals to the great temples aligned with the stars, humans have always recognized the sacredness of the natural world. Philosophers, poets, and scientists alike have drawn inspiration from Earth's beauty. The invention of the telescope allowed us to look outward into the universe, while geology, biology, and ecology revealed the wonders of Earth itself. Perhaps the most profound moment in our relationship with Earth came in the 20th century, when astronauts, leaving the planet for the first time, looked back and saw the blue marble. Suspended against the blackness of space, Earth appeared small, fragile, and breathtakingly beautiful. This image transformed how humanity saw its home, not as a boundless expanse of land and resources, but as a delicate oasis in a vast, unforgiving cosmos. It reminded us that all nations, all species, and all lives share this one planet. Today, humanity stands at a crossroads. Our population exceeds 8 billion. Our cities sprawl across continents, and our technologies extend from the ocean floor to outer space. Yet this progress comes with consequences. Deforestation, climate change, loss of biodiversity, and pollution threaten the very systems that sustain us. We are the first species in Earth's history capable of understanding the planet's fragility, and the first with the power to protect or destroy it on a global scale. Despite these challenges, hope remains. Across the world, movements for conservation, sustainability, and environmental justice are growing. Nations collaborate to protect endangered species, restore forests, and reduce greenhouse gas emissions. Scientists explore renewable energy, reforestation, and sustainable farming, seeking ways to live in harmony with the Earth rather than at its expense. At the heart of these efforts lies a simple truth: humanity's fate is inseparable from the fate of Earth. Our relationship with Earth is both ancient and evolving. From the first sparks of fire in caves to the satellites orbiting overhead, we have always depended on this planet. It has fed us, sheltered us, inspired us, and challenged us. And now, it calls upon us to act as stewards, to ensure that future generations inherit not a barren world, but a thriving one. To rise to this challenge is to honor the greatest gift of all, the chance to live on a planet as extraordinary as Earth. As our story reaches its closing chapters, we return to the question that has guided humanity for ages. What is Earth? At its simplest, Earth is a planet orbiting a star in a spiral galaxy among billions of galaxies. Yet to call it merely, that is to miss the profound truth. Earth is not just a planet. It is a living world, a cradle of life, a sanctuary unlike any other we know in the cosmos. From the fiery birth of its surface to the rise of oceans, mountains, and forests, Earth has been a canvas on which the story of life has been painted. It has endured cataclysms, from asteroid strikes to ice ages, and yet it has continued to nurture and renew itself. Through this resilience, Earth became the only known place where chemistry blossomed into biology and biology evolved into consciousness. It is here, and only here, that the universe gazes back at itself through human eyes. Earth's uniqueness lies not only in its ability to sustain life, but in the diversity of that life. Each species, from the smallest bacterium to the largest whale, plays a role in the grand symphony of ecosystems. Together they form a balance, intricate, fragile, and beautiful. Destroying one thread of this web threatens the entire fabric. Protecting it, on the other hand, ensures that the song of life continues to echo through time. Humanity, as part of this web, carries a dual identity. We are children of Earth, born from its soil and nourished by its waters. But we are also its stewards, endowed with intelligence and foresight to shape its future. The choices we make, how we grow food, use energy, build cities, and share resources, determine whether Earth will remain a flourishing home or slip into decline. The challenges are immense. Climate change warms the atmosphere, melts ice caps, and raises seas. Species vanish at alarming rates, forests shrink, and pollution seeps into air, water, and soil. Yet in these challenges lies a call to action. Earth is resilient, but it is not invincible. It needs caretakers who understand that to harm the planet is to harm ourselves. The path forward is one of unity. Earth does not recognize national borders. Rivers cross them, winds sweep over them, and the climate embraces us all. No matter where we live, we breathe the same air, drink from interconnected waters, and depend on shared ecosystems. To protect Earth requires global cooperation, a recognition that we are one people sharing one planet. And so, the script of Earth's story is not finished. It continues to be written by every human being alive today. Will it be a tale of neglect and loss, or one of renewal and stewardship? That choice rests in our hands. We have the science, the knowledge, and the imagination to preserve Earth's beauty and abundance, not just for ourselves, but for generations yet to come. When astronauts describe Earth from space, they often speak of the overview effect. Looking back at our planet as a small, luminous sphere suspended in darkness fills them with a profound sense of connection, humility, and responsibility. In that moment, divisions fade away. There are no borders, no conflicts, no separations, only Earth, our shared home. Perhaps if we learn to see Earth not from the ground but from the perspective of space, we will finally understand what it means to protect it. Earth is not eternal. One day, in the distant future, the sun will expand and the oceans will boil away. But that day is billions of years away. In the meantime, Earth remains vibrant, alive, and full of promise. It is a gift in the vastness of the universe, and it is ours to cherish. So let us end with this thought. Earth is not just where we live. It is who we are. Its mountains are the bones of our history, its rivers the veins of our survival, its forests the lungs of our future. To honor Earth is to honor ourselves. And to protect it is to ensure that the story of life, our story, continues not as a tragedy, but as a testament to wisdom, compassion, and unity. The planet Earth is more than a world. It is home,